Hello, welcome to this lecture. In this lecture, we are going to present why fat classes are bad. We are going to present a dichotomy between having a class hierarchy and having a large class. Basically, the goal for this class is to present the transform self-type check reengineering pattern. It is good, if you don't remember, to recheck the implementing node lecture. Let's start with an example. We are going to create a program to process bibtext files. Bibtext files are a way of representing documents such as articles, proceedings, books, and have information about their authors, title, the publisher, and the year, and much more information for each of them. As we can see, in this kind of file, we have mixed different kind of entries. We have in proceedings, books, article, text report, PhD, and a lot more. And for each of them, we will have different fields. We will have a key to identify them inside the file, but also we are going to have the year, the institution, the authors, the book title, the title, and these fields change by type of entry that we have. There are some that are common, but some that are unique for each kind of entry. We have a little library that already handles these kinds of files, and it's called Sitesen. Well, in this one, we are representing these entries as instances of the class CZ entry. And we can see that in this one, we are having fields, instance variables to represent all of the fields, keys, types, and all the elements in any given element inside the bibtext. We are having one single class to represent them all. It's common that we will have this kind of pattern of methods. We are having an isArticle method that will return true if the element that we are processing inside the bibtext file is an article, and will return false in all the other cases. The same we have for our isBook. It's checking the type of the object of the entry and returning true or false if it's the correct type. In this case, we are going to have a lot of them, one for each of the types of entries that we have in our bibtext file. This same pattern is happening to us in the field, in the representation of each of the field in the entries, in the bibtext entries. In this case, we are going to have one single class to represent all the fields that we can have in a bibtext entry. In this case, we have exactly the same problem. We were going to be able to identify if a field is of a given type. In this case, for example, if it's the DOI of the document, the DOI is a unique code, international unique code given for each document in the academic world, but it's the same for all of them. Could be is DOI, or we can have if it's title, or if it's the URL, or whatever. We are going to have many of them. How is this impacting us? Well, the consequence of having all these methods to ask of the type of a field is that we have a lot of repetition of this kind of bad pattern. Look what we have in this method. First, the first thing that you should see is that it's a really long method. And also is that it's having a lot of conditional code. We are having different behavior depending the type of the field. If we have here a field that is a PDF, we will produce the output in a single way. If it's a URL, in another way, and so on. Because what this method is doing is printing, generating HTML code, depending the kind of field that we have. But we see that this pattern is really, really evil because it generates a long method that has a lot of conditional code. So, the consequences of having a fat class basically is that we are taking all our naturally existing hierarchy. We have a lot of types of fields, a lot of types of entries, and we are collapsing all them in a single class. So we don't have a class hierarchy, we have a single fat class. As we have only one class, we cannot use dispatch, we cannot use polymorphism. It's not possible to dispatch because we only have one class, and we have to use all these methods, that is book, is title, is URL, and we don't have a nice solution where we use dispatch, and we are breaking the rule that we are always saying, that is tell, don't ask. We want to dispatch instead of having conditional code. When we start adding new types, new in the file or fields, we will have to modify many of these methods. We will have to modify many of these long methods to add new conditional code. And also, if we want to subclass these really big classes with really complex code, we are going to see that we will be starting duplicating and changing and adapting and doing mostly hacks to go over this problem. Every time, as I said before, every time that we add new behavior, we will have to change exactly the same methods and adding more and more conditional code and making it more complex. This is a good example of a problem that we have already talked in the Implementing Node lecture. So if you don't have it in mind, please go back to that lecture and see some of them. In this kind of questions, conditional code that we do, we can call it as type checking, because we are asking all the time, what is the type of the object? We are doing, is a book, is an article? Well, this is not bad per se, but we have to take care when to use it. This is good when we can encapsulate this behavior inside our own class, and we can do self methods. But it's really, really bad when the clients start using them. When these methods are used, these messages are sent from outside our class. So we have to take care of this, and this is an smell that we are doing something wrong, and we have to refactor our code. What we are suggesting in this lecture is, if we have the code in this shape, where we have a client that sends a message M, and this message is implemented in a method where we have different cases using a lot of conditional code, and we are executing different code for each of these cases, we can refactor this, delegating this behavior in a new class. In this case, for example, for the case B, we are going to have a new implementation, and the idea is that we are going to have a new class B that handles that behavior, and only that behavior. For example, B could be our class representing the books, and C could be for our articles, and so on. And the client now will delegate in this object, in these objects, through a new method that in this case we put a generic name hook, but can be any of them, any name. But the important thing is that we are extracting this code that is in each of the cases and putting it each in a separated class. We can, in this case, have or not a common superclass. This depends if we have or not reuse between each of these real objects implementing our behavior. As a conclusion, we have to always favor dispatch. We have to prefer to use dispatch before conditional code. We can create little classes that encapsulate little knowledge. They are cheap to use, they are cheap to maintain, and they produce more clear code than having conditional code. And remember, because this is a mantra that it justifies a lot of our design decisions and that produce a better code quality, do not ask, tell. Basically, delegate before using conditional code. Or if you want in the same order, do not use conditional code, delegate to other objects.